Welcome to this lecture. In the last presentation we completed dual, and in this lecture we are going to study self-dual. Before starting self-dual, let us revise the dual first. We have to switch AND with OR and OR with AND. We have to switch 0 with 1 and 1 with 0, and the final and most important point, we have to keep the variables as it is. So these are the 3 points that you should know in order to find out the dual of the given expression. For any logical expression, 2 times dual gives the same expression. So this is a very important point that you should keep in your mind. If you take the dual of the given logical expression 2 times, you are going to get the same expression. But in case of self-dual, you will get the same expression by 1 time dual. So in normal expression, we have to take 2 times dual in order to get the same expression. But in case of self-dual, we have to take dual only 1 time to get the same expression. We will see 2 examples depending upon these 2 statements. First we will prove this statement, then we will solve for self-dual. Let's say our function is f and it is equal to a and b and c complement, or a complement and b and c, or a and b and c. This is our function, and we will take dual 2 times and we will see if we have the same expression or not. F dash is the function that we are going to have after taking the dual 1 time, and to take the dual we have to switch AND with OR and OR with AND, and we have to keep the variables as it is. So let's start with it. A or B or C complement. We are keeping the variables as it is, and we are exchanging AND with OR, and this OR will now be written as AND. A complement or B or C and A or B or C. So this is what we have when we take the dual 1 time. Again we are going to take the dual. This is the second time we are going to take the dual. We will follow the same steps. We are going to keep the variables as it is. This OR will now be written as AND. This AND will now be written as OR, B and C, or A and B and C. Now you can see that F and F double prime are same. So when you take the dual 2 times, you are going to have the same expression. This is proved. Now we will solve for self-dual. Let's start the problem number 2, in which we will take the dual 1 time and we are going to have the same expression. We will call the function g, and it is equal to a and b, or b and c, or a and c. So this is what we have, and we are going to take the dual only 1 time, and let's see if we have the same expression or not. G prime is equal to A or B and B or C and A or C. Now you will say G and G prime are not same. I told you that 1 time dual will give us the same expression in case of self-dual, but here you will say they are not same, because we have to convert this expression, this obtained result, in this form. For this we have to use the Boolean algebra and do some simplification. So let's start by using the distributive law. Distributive law says x or y and z can be written as x or y and x or z. This is something we already know from our Boolean algebra lecture. I'm going to use this property, and we will try to have this form of expression from this one. So if I use the distributive law in this 2, then I can write B or A and C and A or C. Now again I will use the distributive law. A and B I have, A and C I have, B and C or A and C or C. I have just opened the bracket and I have this result. We will further minimize it. A and A is definitely A and C, B and C. A and C is A and C. These two min terms are same, and we know x or x is equal to x. So I will write A and B or B and C or A and C. Now you can see G prime is equal to G. A and B, A and B, B and C, B and C, A and C, A and C. So we have taken the dual only once and we have the same expression. So this is what we call as self-dual expression, and it is a very important topic. Sometimes you may have questions in your exam. Now there is one trick that I am going to share with you. This is a very important trick. If you have n variables, and you want to find out the self-dual for this n variables, then how many self-duals are possible? If you have n variables and you are willing to find out the self-dual, then we have 2 to the power 2, and again its power n minus 1. So this is a very important trick that you can use in your exam. Let's say the number of variables are 2, then n is equal to 2, and in this case the number of self-dual expressions are equal to 2 to the power 2. Here n is equal to 2, so we have 2 minus 1. If we solve this, we have 2 to the power 2, and the power of 2 will be 2 minus 1, 1. So we have 4. In total, we are having 4 self-dual expressions when the number of variables are 2. Now what are these self-dual expressions? What are these 4 self-dual expressions? If I say A and B are the 2 variables, if we are talking about 2 variables, then the first self-dual expression will be A. If we take the dual of A, we are going to have A, which is same. And if we take the dual of A complement, we will have A complement. In the same way, B will give us B, B complement will give us B complement. So these are the 4 self-dual expressions in case of 2 variables. Now this is all for this presentation. You have one more trick in your bag. You can use it in your competitive exams. Now this is the time for your homework. Let's move to the homework problems. The first problem is to find out whether this given expression, the function y, A complement and B complement, or B complement and C complement, or A complement and C complement, this function y is self-dual or not. You have to find out and you have to answer in the comment section. The second problem is to find out the number of self-dual expressions by using this trick when the number of variables are 4. So these are the 2 homework problems. In first one you have to check whether it is self-dual expression or not, and the second one you have to find out the number of self-dual expressions. Please post your answers in the comment section. This will help others. This is all for this presentation. See you in the next one.